Hey there, for today's question, we have find the range of values of p for which the line y equals to 3x minus 9 does not intersect the curve y equals to negative x squared minus px minus 5p. Okay, first, take note that in the question, eventually the aim is to find the range of values of the unknown p. And where is this p? It appeared in the curve, okay, the equation of the curve. You can see here we have the p here. So we do not know what are the range of values for the p, and we want to find it out. Okay, and this question concerns a line with the equation y equals to 3x minus 9 and its behavior with a particular curve y equals to negative x squared minus px minus 5p. This is a typical A-math question where the question usually tells you the intersection behavior of a line with a particular curve. Okay, so this is actually the idea of discriminants. Okay, and discriminant we have three types. First one, okay, when the line intersects a particular curve at 2 points, okay, then the condition of the discriminant is b squared minus 4ac is more than 0. Graphically, it just means something like this. Let's say I have a particular curve, okay, and I have a line, and the line goes past the curve, goes through the curve, and cuts the curve at 2 points, then it means that the behavior of this, okay, for the discriminant is b squared minus 4ac is more than 0. The curve might also be an inverted U, okay, in the case of a negative coefficient for the x squared term, and if the line passes through or cuts through the curve at 2 points, then again it is also the discriminant b squared minus 4ac more than 0. Okay, that's for the first kind of scenario. We have the second kind where the line is a tangent to the curve. Okay, what this means is, okay, I will show you all graphically later on, but for this type, b squared minus 4ac equals to 0. Okay, so graphically it will look something like this. We have a curve and the line touches the curve at just 1 point. Okay, and if it is an inverted curve, the line just touches 1 point of the curve. It is almost like a hinge. It hinges at 1 point of the curve. Okay, so that is when line is a tangent to the curve, b squared minus 4ac equals to 0. The third type is when the line does not intersect the curve at all. In this case, the discriminant b squared minus 4ac is lesser than 0. Okay, so the behavior graphically would be something like this. We have a curve and the line just does not meet, does not touch, does not intersect the curve at all. You can notice that there is a gap between the curve and the line, and no matter how long we extend the line, no matter how long I extend the curve, the line just doesn't meet the curve at any points. So that is the third condition. Then in the case of an inverted curve, okay, the line is just above it, and no matter how long I draw this line, no matter how long I extend the ends of the curve, the line simply does not meet the curve anywhere. So that's when b squared minus 4ac, the discriminant, is lesser than 0. So with these three conditions, let's go back to the question again. The question clearly states that the line does not intersect the curve. Okay, so now it is very obvious that this question is talking about the third scenario, where the line does not intersect the curve at all, and the discriminant b squared minus 4ac is lesser than 0. Okay, so great, we have gotten this clue. Okay, and that's almost like half the job done. Okay, so now I would just separate this paper, okay, the top and the bottom for the workings later on. So with this clue, how should we start first? Firstly, okay, it is a standard procedure that we equate the equation of the line with the equation of the curve. So just put the first equation, or rather the first expression, on the left hand side. Okay, this is the equation. Previously, y equals to 3x minus 9 is the equation of the line. We equate this with negative x squared minus px minus 5p. Okay, so just equate the two equations and do something like this. Put them side by side. Okay, after that, bring the terms over to one side. So let's say I choose to bring the terms on the right to the left. Then the second step will be 3x minus 9. Since I'm bringing these over, the signs will change. So from negative, when I bring over plus x squared, when I bring over plus px, and when I bring the negative 5p over, it will be a plus 5p. Okay, and there will be nothing here on the right hand side, so it's equals to 0. Okay, so with this, we can start to simplify these and rearrange some of the terms. We always put the x squared term in front, followed by the x terms, then the constants. So I have x squared plus px plus 3x. Okay, and I will just group them together to be plus p plus 3 in brackets and my x term outside. Okay, next I would lump or combine the constants. So I have a plus 5p and a minus 9. So in a group, they will be 5p minus 9. Okay, and don't forget, they are equals to 0. They are equal to 0. Okay, so with these, I have a proper equation, x squared term, x term, and the constants. Okay, so pause here, go back to what we found out earlier on. The discriminant b squared minus 4ac must be lesser than 0 for the line to not intersect the curve. So now you may ask, what is the b? What is the a? What is this c? Very simply, okay, the a term refers to the coefficient in front of the x squared. Okay, in this case, the coefficient is 1, but by convention, we do not put 1 in front of x squared. We write it simply as just x squared. But we do know that there is an invisible 1 in front of the x squared term. Okay, the b term is actually the coefficient in front of the x term. So the b stands for the coefficient in front of the x term. Then now the c. The c represents the constants collectively. Okay, it does not just represent 5p, nor does it just represent negative 9. It represents 5p minus 9, all the constants collectively as a group. Okay, so now with these understood, we'll move on and write down the condition. B squared minus 4ac must be lesser than 0 for the line to not meet the curve, which is what the question wants. Okay, so with this, let's just put the b, the a, and the c inside. So b squared would be p plus 3 whole thing squared minus 4 times a, which is the invisible 1, so I'll write down 1. And lastly, my c, okay, is all the constants collectively, so it will be 5p minus 9, close the bracket, and all these, don't forget, it is lesser than 0. Okay, so with this done, naturally the next step is to expand some of the terms. So this will be, okay, the identity a plus b whole thing square. Okay, in Sec 2 math, we have learned that this is a square plus 2ab plus b square. Okay, so the a represents the p here, and the b represents the 3 here. Okay, so it will be, after expanding, p square plus 2 times p times 3, okay, plus b square, which is 3 square, and that gives us 3 times 3, 9. Okay, minus 4 times 5p, so that's minus 20p. Minus 4 times negative 9, it will give a positive 36. And don't forget, all these is lesser than 0. So now we will simplify these expression on the left. P squared plus 6p plus 9 minus 20p plus 36 lesser than 0. Some students might have the tendency to forget to write these sign, this inequality sign, okay, on the right hand side. So please do watch out and remember to write this down. Okay. After that, we will simplify this whole expression further. So p squared plus 6p minus 20p. Okay, 6 minus 20 will give us negative 14p. Okay, then we have a plus 9 together with a plus 36, and that will be plus 45. And remember, lesser than 0. Okay, and from here, next step, we have to factorize this quadratic expression. So what we do is, okay, using the methods that you've learned in Sec 2 factorization of algebraic expressions, okay, you will arrive at this p minus 9, p minus 5 lesser than 0. Okay, so once you have this here, the next step is we want to sketch a simple graph, okay, for this expression so that we are able to find out the range of p's that are lesser than 0. That we are able to find the range of p's where this whole graph is lesser than 0. Okay, so in this case, let's just draw our y-axis and our x-axis. Okay, and from here, when p minus 9, p minus 5 is lesser than 0, first determine the x-intercepts, or here the p-intercepts. In this case, it's no longer x but rather p. Okay, because it is in p form. So we know that one of the intersect will be 5, because p minus 5, okay, when y equals to 0, p will be 5. When y equals to 0, p would be 9. Okay, and we draw the curve. Taking note that this curve represents this equation, p squared minus 14p plus 45. Okay, and since this is a positive coefficient in front of the p squared term, the curve should be a U shape. Okay, and with this, since the condition is that this whole equation is lesser than 0, it would mean that we are looking at the portion of the graph where y is lesser than 0. So this line, okay, the p-axis and the y-axis, okay, they will meet here where y equals to 0 and where p equals to 0. So when we are looking at y lesser than 0, we are looking at the portion of the graph that is below the p-axis, correct? Because all these segments here, this whole segment is when y is lesser than 0. So the part of the curve that's below the p-axis is definitely this portion here. Okay, so with this, we will know that for y is lesser than 0, p is actually within the range of 5 and 9. So that's our answer for this question. Okay, so going back, just look at it for one last time. Okay, thanks for watching.